Thank you so much. Hey, everybody. Thank you for joining the session. Today, I'm going to talk about the OWASP API Top 10 and the evolution of this project over the last few years. Um, just a few words about myself. My name is Inon Shkedy. I'm the head of security research at Traceable AI, which is a startup in the field of API security. I got 10 years of experience in application security. I performed many pen tests, and I grew up with APIs. What does it mean? Basically, I got most of my experience when I used to serve in the Israeli army in Israel. And I used to perform pen tests for very traditional applications, like government, military, and financial. And as you could imagine, those systems are heavily based on traditional technologies, like Java, ASP.NET, SAP, and traditional concepts like multi-page applications, on-prem environment, waterfall. And APIs used to be just a niche component, mostly for B2B communication. After 5 years in the Israeli army, I moved to California, to the Silicon Valley, and I got exposed to a new field of technologies, like Ruby on Rails, Node.js, and very new concepts, like single-page applications, cloud environments, CI/CD. And the most important part, all these technologies are heavily based on APIs. So APIs became the main component of the application. The next thing that I figured out is I can't really find the traditional stuff I used to find in Israel, like the traditional vulnerabilities, and I had to change my mindset in order to stay relevant in the field and to find vulnerabilities in APIs. And this is how I got into the API security field. So today we're going to talk about OWASP. What is OWASP? What is the OWASP Top 10 and the OWASP Top 10 for APIs, and the new trends in API security that led us to change the list for 2022. So OWASP is an open source organization. It's a non-profit organization. It's driven by the community. And the goal of this organization is to educate developers about best practices when it comes to application security. Every few years, OWASP publishes the OWASP Top 10, which is the list of top 10 vulnerabilities when it comes to application security. And what happened in 2019, Erezi Alon from Checkmarx, who is a friend of mine, told me, listen, we have to create a new list for APIs because the traditional list for like the OWASP Top 10 is not very relevant for APIs. The things change a little bit. And this is where we started working on the new list for the OWASP Top 10 for APIs about 4 years ago. It got out of traction, and basically many things changed in the last, since 2019, and this is why we're going to publish a new version of the list. I'm going to talk a little bit about the changes between traditional and modern applications. So basically, a lot of the heavy lifting moved from the backend to the front end when it comes to application development. For example, the rendering component moved from the backend to the front end because today the rendering is done on the client side, and it's changed many things when it comes to application security. Let's review some of the changes. For example, things like SQL injection became less and less common because developers choose to use ORM environments. The reason why they choose to use them, it's not because security, just because it's more convenient to use, it's easier to use. Cross-site scripting, the responsibility to prevent cross-site scripting moved from the backend to the front end. Things like XXC, which is the vulnerability in the parsing process of XMLs, it's something that you can't really find today for the simple reason that developers choose to use JSON instead of XMLs. Together with the good news, we also have bad news. First of all, APIs expose a much larger attack surface. What's the reason for that? Is because today an application exposes much more entry points to the application, much more parameters that can be sent from the client side. And if you ask every pen tester, they would tell you that the more parameters you have to send to the application, the larger the attack surface, the more places you have to try to inject something, to manipulate the input, and so on. On top of that, APIs are oversharing. They expose the underlying implementation of the application, and they are much more predictable. For example, if back in the day, in order to guess the admin path of an endpoint, you'd have to guess like many components of the URL. Today, it's much more simple. You can, for example, get an API endpoint like get/user/ID, and just change the get to delete, and you get an admin endpoint to delete a user that shouldn't be exposed to the regular user. 2022 list, we had a new leader to the project, Paulo Silva from Portugal. We followed API security trends over the last 4 years, from bug bounty reports, public breaches, reports from different vendors, etc. And the list is becoming less and less similar to the OWASP top 10. So it becomes like a new branch with many exciting changes. This is the initial draft. We haven't published it publicly yet. So it's not like the final version, but this is how it's going to look like. I'm going to talk about the items from the list, what we added and what we removed. First of all, new items. We decided to add a new authorization item, which is broken object property level authorization. We added SSRF, lack of automated threat protection, which is in the field of bots mitigation, and unrestricted resource consumption. We decided to remove a few items as well. First of all, we decided to say goodbye to injections because we see it less and less common in APIs. And the same thing for insufficient logging and monitoring. We don't see it necessarily as a pure API issue. This is something that every component on your system needs to have, like insufficient logging and monitoring. So we decided also to remove it from the list. We combined mass assignment and excessive data exposure into one item and expand a few other items. I want to talk about the biggest risk when it comes to APIs. We have 3 different vulnerabilities that are specifically about authorization, but almost every item on the list has some sense of authorization. Because today, the biggest risk of APIs, and I think this is something that every security engineer would agree with me, is that authorization is the hardest component to implement and tend to be the most vulnerable. Why is it so challenging? Great question. I don't think there is one answer. I believe there are 2 main reasons why authorization became such a big challenge when it comes to APIs and model applications in general. First of all, it's not something that is done in one component in the application. For example, if you think about authentication, this is something you can implement in 1 or 2 components, like maybe you have one team that is responsible for authentication. When it comes to authorization, it's very different, because this is the responsibility of almost every developer in the company. In the function level, it's something that can be implemented on the code, configuration, sometimes on the API gateway. But when it comes to the object level or the object property level authorization, this is the responsibility of every developer that writes code, that receives IDs from the client and fetches and accesses an object from database based on this ID, which basically means every developer that writes APIs. Because this is a very common pattern in APIs, to receive IDs from the client and to fetches IDs based on this ID. The second reason is that you have more complex hierarchies and roles when it comes to modern applications. For example, if we talk about some health provider application, you can see that they have different groups of users. They have patients, care providers, and admins, and then you might find like kind of weird patterns, like one user that has two sub-users, or one user that belongs to 2 different groups, like Jack here. I want to talk about the 3 different layers of authorization and authorization problems that they expose. The first one is broken function level authorization, BAFLA. So I'm going to give the Airbnb app as an example. I never tried to breach the Airbnb app, but I think it's a good example for like a modern application. So think about the following scenario. You're a guest and you want to make a reservation on Airbnb. You need to wait for the host to approve your stay, right? And for that, the host has an API endpoint of post/API/host/accept reservation. What happens if you are trying to access this endpoint as a guest? If the developers don't validate that you are actually a host, this is a broken function level authorization because you are unauthorized to access this function because of your type of user. Okay, so the developers actually verified that you are a host and you don't have BAFLA, but then you have the risk to be exposed to BOLA, broken object level authorization. So in this scenario, you are a host and you're trying to accept a reservation on behalf of someone else, okay? You have like the accept reservation and the ID of the reservation, which is 919. What happens if you're trying to change it to 918, for example, and accept reservation on behalf of someone else? This is broken object level authorization. This is the most common vulnerability today in APIs. I find it personally in 95% of the APIs that I test. Many times it can lead to like account takeover, to information disclosure, like steal information of other users and so on. And then the new category of authorization is object property level authorization. We call it BOPLA. This is the new category that we added. Basically, let's say that you are a host and you are actually trying to access your own reservation and the developers verifies that. What happens if you're trying to edit a property of the object? In this case, the object is a reservation. You're trying to update a property that is internal, that you're not supposed to access, like the total stay price. So the guest had agreed to pay a specific amount of money, let's say $100 for the stay, but then you're trying to edit this property and change it to a very long number, to the total stay price to like $1 million. Because the developers don't check that you have authorization, that you're allowed to access this specific property and to change it, it's vulnerable to BOPLA. A new thing when it comes to the list, we are seeing a lot of bot activity recently. This is why we added the lack of automated threat protection. Protection against bots becoming more and more challenging because, first of all, bots becoming more profitable. And we have another talk here in this track about bot mitigation. You can learn more about it. There are many hackers that find very creative ways to make bots more and more profitable. They're becoming smarter and more human using AI and machine learning. And also, like authorization, the protection against bots is not generic, and it really depends on the business needs. One category that we added to, like one thing that we're gonna talk about in the new list is the scalping bots. Are you guys familiar with scalping? Yeah. So, what's shared between sneakers, COVID masks, tickets, and PS5s? All of them were targeted by scalping bots. What is a scalping bot? It's basically a bot that the goal of the bot is to buy all the stock for a specific item is a very high demand. So, for example, with PS5, once different merchants publish like the PS5, the scalping bots just bought all the stock and resold it on different websites for a much higher price. This is an emerging threat, and we see that the way that scalping bots work is using APIs. Another item we added to the list is SSRF, and I just want to talk about something I forgot to add about bots. When it comes to bots, we are not talking about an implementation bug. It's not like injection, that you actually have like a bug in the way that you implement the code. It's more about the developers didn't think how the API could be abused and harm the business if it's used excessively by a bot. So the protection against bots is more tricky. There is no like straight lines how you should protect against bots. It really depends on the business needs. And also different businesses have different risks. For example, if you're an e-commerce website, you would have different types of risks if you're a social network. Because if you're a social network, you would try to protect against fake comments or maybe like credential stuffing. But if you're in e-commerce, you might be more concerned about scalping, carding, and other types of bots. There is a project called OWASP Automated Threats that describe different types of bots. SSRF, this is another very common vulnerability in APIs. Also, Jonathan here is going to talk about SSRF in, I think, after me or two presentations after me. Basically, SSRF is a vulnerability that you have an endpoint in the API that receives a URL. For example, you have an endpoint to upload profile picture from URL, and you provide the URL of the picture, and then the API is trying to fetch the picture from a different website. This is very common in APIs and modern applications. So in a legit flow, the user would just send, like example.com/image.jpg. But what happens if I send, as an attacker, this is like a malicious payload, I send like a URL that represents a very large file. And then the API is trying to download a very large file. I might cause denial of service. This is one use of SSRF. On top of that, you can use SSRF to scan the internal network and a bunch of other stuff, malicious stuff. SSRF and APIs became more dangerous because of many concepts like Kubernetes API gateways and Docker, for example. They expose HTTP interfaces, basically REST APIs, to access those management consoles. And you can exploit, you can use them as you exploit SSRF. You can use those to basically to make progress in the way that you exploit the API. It's easier to exploit SSRF, and also SSRF became more common because of concepts like webhooks that just encourage developers to take input from the user and access the URL based on this input. Inventory blind spots. We expanded improper asset management and a few other things. For example, if you have an API that exposes 4 endpoints, and like the developers have documentation for the payment, for the post review and the search, but nobody knows what is the old export user data. This is an old endpoint with no documentation. This is a dangerous spot in your APIs. The same way you can have complete APIs that have been forgotten. This is something that I see almost in any company that I test, especially bigger companies. Airbnb might have Airbnb.com, the user API, they know about it. Same thing for the Airbnb.com/host API. But then if you ask the DevOps team, what is qa3.airbnb.com/backup API? And it told us, oh, actually, we don't really know. There is like a developer that left the company 3 years ago, and she just left it there. So we are too scared to remove the API to break something. And it's something that you see a lot. And many times those APIs run older versions, they have less protections, and they become more dangerous. Sometimes on top of that, you can see that developers expose Intel microservices to the internet that shouldn't be exposed publicly. And the last type of inventory blind spots is that you have some data flow. For example, on Airbnb, Airbnb has partners. So you can, if you're a host, you can manage your Airbnb account using like different applications that work together with Airbnb. One of them is Shkedy, and it helps you to manage taxes and other stuff when it comes to to the Airbnb host. And for this communication to happen, there is a sync API between the tax microservice of Airbnb and the Shkedy API. And basically, if you have information that is shared with the other world, like with third parties, you need to know which data is transferred between those APIs. Many times companies don't have visibility into those data flows, and this is another type of inventory blind spot. The last point I want to talk about is that there are many new protocols when it comes to APIs. It's not only REST APIs. We also have GraphQL, gRPC, WebSockets, and we have been discussing the leadership team with the community. What should we do with these protocols? Should we create a new category for GraphQL? We end up deciding that the risk for GraphQL and the other protocols are very similar to the risk when it comes to REST, and this is why we're going to add examples for each one of these protocols under the existing categories to cover GraphQL and gRPC. I think now it's time for questions.
If anyone has any questions.
So first, thank you for the presentation. If I understand it well, for the moment, the top 10 is not yet published. It's still a draft. When will it be available for this year?
Sorry, can you repeat?
When will it be published?
We're going to publish the draft in January. We are about to send it to the initial list of reviewers today, and then after 2 or 3 weeks, we're going to publish the draft to the community. We will get feedback from the community. Based on this feedback, we would change the list and publish the final version.